You may have heard about a major collaborative research project being carried out by the main proponents of two major theories of consciousness, IIT and global neuronal workspace. Some developments have taken place in that project, so I'll talk about it here today. The following is from an editorial in the journal Science written by Elizabeth Finkel, titled Adversarial Search for Neural Basis of Consciousness Yields First Results. Finkel writes, quote, "For the collaboration funded by the Templeton World Charity Foundation, both sides of the consciousness debate agreed on experiments to be conducted by theory-neutral labs with no stake in the outcome. It pits integrated information theory, IIT, the sensory network hypothesis that proposes a posterior hot zone as the site of consciousness, against the global neuronal workspace theory, GNWT, which likens networks of neurons in the front of the brain to a clipboard where sensory signals, thoughts, and memories combine before being broadcast across the brain," unquote. Finkel continues, quote, "For the GNWT versus IIT phase of the project, Mudrick and the two other independent project leaders, psychologist Lucia Melloni at the Max Planck Institute for Empirical Aesthetics and Michael Pitts at Reed College, spent a year working closely with Dehane and Giulio Tononi, a psychiatrist and neuroscientist at UW-Madison and chief architect of IIT, to design two experiments for which each theory offered clearly distinct predictions. Dehane and Tononi would have no role in performing the experiments or writing up the results. The team pre-registered the experimental design on an open science website, outlined the approach in a 2021 perspective in Science, and published the details in February 2022. 6 theory-neutral labs would scan the brains of 250 total participants using 3 techniques: functional magnetic resonance imaging, magnetoencephalography, and electrocorticography, in which electrodes are placed on the brain's surface prior to a surgery. The first of the 2 planned experiments showed participants images with and without an accompanying task, pressing a button in response to either of 2 target pictures, so researchers could look for differences in the resulting brain signals. IIT predicts that passive perception will activate the back of the brain, but perception while performing tasks will spark the front. GNWT predicts similar brain activation in the 2 situations. Key to the experiment were algorithms called multivariate pattern decoders, which could predict which image a participant was viewing at a given time based on their brain signals. Researchers initially trained these decoders by feeding them examples of that participant's brain activity data along with the corresponding image. GNWT predicts that the frontal network supporting both active and passive perception should be similar enough to allow the decoder to cross-train. That is, if it's been trained only on signals related to the task of passively observing a face, it should still be able to decode data from the task of pressing a button in response to a face. IIT predicts that cross-training will only work well with brain signals from the posterior regions, the proposed site of conscious perception. The results, which the team published in a 26 June preprint, were surprisingly mixed. When it came to decoding different categories of objects, the data provided strong support for GNWT, but when it came to decoding the orientation of faces, IIT was the better fit. In another analysis, the tables were turned. During conscious perception, IIT predicts neural communication within posterior areas, whereas GNWT predicts it should be between visual and frontal zones. And in the study, the expected communication patterns were in line with GNWT, Mudrick says. The timing of the recorded signals, meanwhile, offered stronger support for IIT. In the posterior region, activity persisted as long as the image was presented on screen, as IIT predicts. GNWT instead predicts an initial spike of activity, the ignition of the frontal workspace, and another spike when the stimulus disappears. That theory scored a partial win. There was evidence for an initial spike, but not the off spike, unquote. As the author said, these results were just released as a preprint, the first set of results from the planned experiments. Now I'll go over to the preprint itself and share some of what it says. This was apparently released at Cold Spring Harbor, and the number of authors is extensive, including Stanislas Dehaene, Christoph Koch, Lucia Melloni, David Chalmers, and Giulio Tononi. The title is An Adversarial Collaboration to Critically Evaluate Theories of Consciousness. The authors write, quote, IIT and GNWT explain consciousness differently. IIT proposes that consciousness is the intrinsic ability of a neuronal network to influence itself as determined by the amount of maximally irreducible integrated information, phi, supported by a network. Theoretical and neuroanatomical considerations indicate that a complex of maximum phi likely resides primarily in the posterior cerebral cortex in a temporal-parietal occipital hot zone. GNWT instead posits that consciousness arises from global broadcasting and late amplification or ignition of information across interconnected networks of higher-order sensory, parietal, and especially prefrontal cortex. Although GNWT holds the workspace to include prefrontal cortex and inferior parietal cortex, in this adversarial collaboration, we focused on the PFC, prefrontal cortex, as GNWT and IIT pose the most incompatible and hence maximally diagnostic predictions about this brain region. We tested 3 core contrasting predictions of IIT and GNWT for how the brain enables conscious experience. Prediction number 1 pertains to brain areas in which conscious content should be found. IIT predicts that conscious content is instantiated primarily in posterior brain areas, while GNWT predicts a necessary role for prefrontal cortex. Prediction number 2 pertains to how conscious percepts are maintained over time. IIT predicts that conscious content is actively maintained by neural activity in the posterior hot zone throughout the duration of a conscious experience. GNWT predicts instead that an ignition in prefrontal cortex at stimulus onset and at offset updates the workspace with activity silent maintenance of information in between. Prediction number 3 pertains to interareal connectivity between cortical regions during conscious perception. IIT predicts short-range connectivity within posterior cortex, including lower-level and high-level category selective areas. In contrast, GNWT predicts long-range connectivity between high-level category selective areas and prefrontal cortex. This combination of predictions places a uniquely high bar for either theory to pass, especially considering the highly powered and multimodal studies we conducted. Finally, an additional goal of this experiment was to narrow down the cortical areas potentially participating in consciousness by excluding those reflecting confounding cognitive task-related processes, unquote. Reading these predictions, I immediately wanted to see what my own framework, the Temporally Integrated Causality Landscape, TICL, would say. Let's give that a try. Prediction number 1 is about which brain areas are involved in conscious perception. IIT places it in posterior cortex, but GNWT says that the prefrontal cortex must be involved. I agree with IIT. I think prefrontal cortex could be involved or not, but that direct perception of content does not require it. According to the TICL, subsystems should be composed of a large but limited number of neurons influencing each other at a higher level than the whole system is influencing them or being influenced by them. In other words, a local set of neurons has a higher level of temporally integrated causality than the whole system has. This local activity thus rises out of the background and produces conscious content. Systemic activity provides a background or a threshold over which the subsystemic activity arises. When it does so, from the point of view of the system, there is specific qualitative content. Prediction number 2 is about the duration of activity. IIT predicts that activity is maintained for as long as the content occurs. The TICL totally agrees. In fact, if this is not the case, then TICL is in serious trouble. I explicitly predicted that the conscious content remains present precisely as long as the subsystem does. As soon as the local subsystemic activity is no longer higher in temporally integrated causality than the whole system is, the content will disappear. But there is no way for the content to persist beyond the existence of the subsystem. As for prediction 3, I expect that both short and long-range activities are necessary. The system is large and thus requires long-range connectivity, but a subsystem can be local and short-range, nested within the larger system. I guess this position is intermediate between the two theories being compared in these studies. Now I'll go on to the results these authors reported in the first preprint. They write, quote, "In posterior cortex, the results of the LMMs revealed 25 electrodes that exhibited sustained activity that tracked stimulus duration in line with IIT's prediction. A subset of 12 electrodes showed sustained duration tracking irrespective of stimulus category, predominantly in early visual areas. The remaining 13 electrodes showed category selective tracking, mostly to face stimuli localized to the ventral temporal cortex. Overall, the proportion of electrodes showing category-specific and duration tracking was small, e.g., only 15% of face-selective electrodes showed sustained duration tracking as predicted by IT, pointing to a sparse underlying neural substrate. These responses mostly localized to the lateral fusiform gyrus. The remaining face-selective electrodes exhibited transient activations at stimulus onset, localized across striate, extrastriate, and ventral areas. In prefrontal cortex, 99 and 24 electrodes showed non-selective or category-selective onset responses, respectively, yet none of the 655 electrodes tested matched the temporal profile predicted by GNWT, i.e., onset and offset. This null result was not due to the analysis approach, as the LLMM was indeed sensitive to picking up the pattern predicted by GNWT in 10 electrodes outside the predicted ROI. An exploratory analysis to decode stimulus duration with unrestricted temporal profiles and time windows revealed a single electrode in the inferior frontal sulcus showing the GNWT predicted pattern, yet earlier than expected. The very same electrode exhibited a biphasic event-related potential with a positive deflection early on and a negative deflection at a later latency. Additional control analyses, including time locking the analysis to stimulus offset, corroborated the temporal profile predicted by IIT in posterior areas and the absence of the temporal profile predicted by GNWT in prefrontal cortex. For magnetoencephalography, we used LMMs to investigate the temporal patterns of gamma frequency band power within posterior cortex and PFC. Even though gamma frequency band activity was strong in posterior areas, none of the theory-based models provided a good fit to the data. Results on alpha frequency in IEEG and magnetoencephalography were inconclusive and did not provide strong support for either of the theories. In IEEG, none of the prefrontal electrodes showed onset and offset response, but instead this pattern was found in posterior sites. In magnetoencephalography, temporal profiles consistent with GNWT were found in most areas in posterior cortex and in the anterior cingulate cortex, but those results were highly dependent on parameter choices, and contamination from posterior sites could not be ruled out. Together, the results from the temporal activation analysis support IIT's predictions of sustained activation within posterior cortex. In contrast, we found no evidence in IEEG for the GNWT prediction concerning late phasic ignition of prefrontal cortex at stimulus onset and offset, despite the presence of robust ignition at the onset of the stimuli. Evidence in the alpha band from magnetoencephalography was inconclusive, but not supported by IEEG, despite the ample coverage of prefrontal cortex. This pattern of results challenges GNWT's predictions, unquote. One thing I like about this adversarial approach is that the mix of authors with their own biases in favor of IIT or global neuronal workspace keeps the results and the discussion more honest than it might otherwise have been. This means that any debates that need to take place between the camps are accomplished prior to the manuscript being submitted for review. Here's some of the discussion at the end of the paper. The authors write, quote, "The results corroborate IIT's overall claim that posterior cortical areas are sufficient for consciousness, and neither the involvement of prefrontal cortex nor global broadcasting are necessary. They support pre-registered prediction number 1, that decoding conscious contents is maximal from posterior regions, but often unsuccessful from prefrontal cortex, and prediction number 2, that these regions are sustainedly activated while seeing a stimulus that persists in time. They do not support prediction number 3 concerning sustained synchrony, although there are potential explanations. Below, we illustrate how these predictions were motivated by IIT. Posterior regions are often considered mere information processors. Their activation, it is claimed, may be necessary but not sufficient for experiencing specific contents. For example, they may show activations during deep sleep or anesthesia and for unreported stimuli under contrastive near-threshold paradigms. This seems to warrant the need for additional ingredients such as global broadcasting or higher-order monitoring by prefrontal cortex. For IIT, however, posterior regions are sufficient for consciousness as long as they satisfy the requirements for maximal integrated information. Why this prediction? Unlike other approaches, IIT infers the essential physical requirements for the substrate of consciousness from the essential properties of experience. This leads to the claim that the quality and quantity of an experience are accounted for by the cause-effect structure specified by a substrate with maximal integrated information, called the main complex. We conjectured that posterior cortical regions should provide an excellent substrate for the main complex owing to their dense local connections arranged topographically into a hierarchical, divergent, convergent 3D lattice, leading to prediction number 1. Nevertheless, by IIT, posterior regions can only support consciousness if their physiology ensures high integrated information, which indeed breaks down to bistability when consciousness is lost in deep sleep and anesthesia. Much of prefrontal cortex, in contrast, seems to be organized not as a grid, but as a patchwork of segregated columns, unfavorable for high integrated information. Even so, any prefrontal cortical region organized in a grid-like way with dense interconnections with posterior regions may well be part of the main complex. As previously emphasized, we bear no preconceived enmity to the prefrontal cortex. Indeed, searching for the neural correlates of consciousness of specific aspects of experience in certain anterior regions is an important task ahead. For example, parts of IFG might contribute to, say, an abstract, evaluative, actionable experiential aspect of faces, which could be consistent with some PNCC analysis results. However, IIT predicts that we would still experience faces if PFC were selectively inactivated. For IIT, all quality is structure. All properties of an experience are accounted for by properties of the cause-effect structure specified by the main complex. Every conscious content is thus a structure, substructure of integrated information, irreducible cause effects and their overlaps. It is neither a message that is encoded and broadcasted globally, nor a distributed activity pattern, nor a neural process. Indeed, IIT's research program aims to account for specific consciousness contents, why space feels extended, time feels flowing, and phenomenal objects feel like binding general concepts with particular features, all exclusively in terms of their corresponding cause-effect structures, unquote. Goddamn. I never read the 2022 Integrated Information Theory 4.0 paper, which they cite here, in talking about a substructure of integrated information and overlapping irreducible cause effects. I think this was influenced by my own work, which came out in 2020. I went over to the IIT 4.0 paper, and it doesn't cite my paper either. I recognized the possibility of convergent thinking, but if they were aware of my work, as they should have been when they wrote that manuscript, I should have been mentioned. In any case, I don't see how IIT can accommodate substructures as long as it holds to the exclusion principle. In my opinion, the exclusion principle is untenable, and IIT should be reformulated to get rid of it. In effect, IIT should accommodate the TICL. Then I wouldn't need a separate framework, as IIT would satisfy what I'm calling for in a theory of consciousness. I'd have to become an IIT guy. Maybe that's coming down the road at some point. But it would take a major revision of IIT, which would upset most of the previous investigations that have been done in modeling phi-max and all the rest. In the absence of certain presuppositions in IIT, as I see it, the theory gets flipped over on its head. In the TICL framing, the maximum cause-effect power would occur in a subsystem. The system, which is much more global, is integrated but to a much lower level and over a broader timescale. The subsystems will actually have higher phi measures than the system overall. Thus, from the perspective of the system, the subsystems exist more than it does. The system, or conscious being, does not see itself. It sees contents, which are subsystemic activities. This first preprint is supportive of IIT and the TICL relative to global neuronal workspace. The experiments that were carried out would not be able to distinguish between IIT and TICL because they're actually pretty similar proposals fundamentally. I have no animosity toward IIT. I just recognize some fatal flaws in it. The TICL was my solution to those flaws. However history plays out, I think something like my theory will be arrived at, maybe a decade from now, maybe longer. When it is, I'll either be written into that history or written out. I want to be a part of it, and I think my ideas can shorten the time it takes to get there substantially. I guess we'll have to wait and see.